In section 6.4, we're factoring trinomials again, but we're going to call this the AC method because these trinomials are of the form ax squared plus bx plus c, meaning they're going to have a coefficient other than 1, okay? The trinomials in section 6.2 would just say, x squared plus bx plus c, but this time there's going to be a number in front of the x squared. And the way that we're going to do this, it's going to be similar to last time, but like you're always going to factor out a GCF first. When you're factoring, you're going to always look for a GCF first. There's not always one, but you have to look for it first. Okay, and this is where it gets a little bit different. You're going to multiply the coefficients of the first and last terms, as in A and C. A and C, that's why it's called the AC method. Okay, once you do that, you want to find two numbers that multiply to give you AC, but add to give you B. And I'm going to even go as far as writing multiply and add. And in that last section, you saw me write a statement. I would write, oh, we're multiplying to get this, and we're adding to get this. We're going to do that same thing again, okay? Anyway, once we find those two numbers, we're going to rewrite the B term that's in the middle. So this guy right here, we're going to rewrite it. And then we're going to factor by grouping. This is just a little exercise to practice. Find two numbers whose product is negative 18 that add to give you 7. And if you're multiplying to get a negative, your signs are different. And if you're adding to get a positive 7, your larger sign's positive. So write down all the factors of 18, 1 and 18, 2 and 9, and 3 and 6, 6 and 3, you started repeating. Since your larger number is positive, that means your smaller number will be negative. So it looks like it's going to be 9 and negative 2 that add to give you positive 7, but multiply to give you negative 18. Right here we have a positive 20 and a negative 9. So if you're multiplying to get a positive, your signs are the same, either both positive or both negative. But you're adding these two same signs to get a negative 9, so they would both need to be negative. So if you think about 20, you got 1 and 20, and 2 and 10, and 3, 4 don't go in. 4 goes into it 5 times, 5 and 4. So you start repeating, you can stop. And if they'll both be negative, what adds to give us negative 9? Negative 5, negative 4, or negative 4 and negative 5. Okay, so for and those two problems were just an exercise really to get us ready for factoring using the AC method. Now, the first thing that you want to do when you're factoring always is to look for a GCF. Okay, so 3x squared, 14x, 8. They don't have anything in common. I can't pull out a GCF. So from here, the first step would be to multiply 3 and 8 to get 24. So this means that we're going to look for two numbers that multiply to give us 24, but add to give us the middle number of 14. You're like, whoa. Why can't you use 8 and 3? 8 and 3 multiply to give you 24. That's what I multiplied to get 24, right? Yes, but 8 and 3 do not add to give you 14. So we're going to have to look for it. We're multiplying to get 24, which is a positive, so our signs are the same. And since you're adding to get a positive 14, they're going to both be positive. So 24, the factors are 1 and 24, 2 and 12, 3 and 8, 4 and 6, 6 and 4. You start repeating, you can stop. The signs are both positive. So what adds to give you 14, 2 and 12? The next step, and you might want to be following along in the steps up here. So far I've looked to see if there is a GCF, and there's not always a GCF. Step 2, I've multiplied A and C. In step 3, I have found the two integers who multiply to give me AC but add to give me B. Okay, step 4 is in reading this, it's kind of weird to try to just read it and understand. Rewrite the middle term BX as the sum of two terms whose coefficients are the integers found in step 3. So basically what I'm doing is I'm going to rewrite the trinomial of 3x squared plus 14x, except I'm going to leave a space and not write 14x right there. I'm going to go ahead and write plus 8 on the end. And right here in the middle, where the 14x was, instead of writing 14x, I'm going to put plus 2x plus 12x. And would you know that this is equal to the original? I took a trinomial and turned it into a 4-term polynomial, which I can now factor by grouping. It's completely okay to do what I just did because 2 and 12 add to give me 14. It's the same thing. But now I have, again, a 4-term polynomial that I can factor by grouping. Also, you could have written this as plus 12x plus 2x. The order in which you write them does not matter. Anyway, so to factor by grouping, and then you can go and review that if you need to in section 6.1. The front binomial has a GCF of x, and if you factor that out, you're left with 3x plus 2. And this back binomial has a GCF of 4, and if you factor that out, you're left with 3x plus 2. So now there's a 3x plus 2 in common, and you're left with x plus 4. Do know that you can multiply this back out. You can FOIL it back out to check and see if you get your original. I'll do that really quickly. 3x times x is 3x squared. 3x times 4, 12x. 2 times x is 2x. 2 times 4 is 8. So 3x squared plus 14x plus 8. And that's the original. So my binomials look like they were correct. Okay, so now 2h squared plus 7h minus 15. Look for GCF first. No GCF. Okay, 2h, 7h, 15. Can't take out an h. 2, 7, 15 don't have anything in common. So multiply a and c together. That's negative 30. So you're looking for the things that multiply to give you negative 30, but add to give you 7. I was about to write 7h. Anyway, if you're multiplying to get a negative, your signs are different. Since you're adding to get a positive, your larger number is positive, the smaller one's negative. So let's write the factors of 30. I'll just say 30. 1 times 30 is 30. 2 times 15. Okay, so I started repeating. Now, go back and think about what I wrote up here. The positive will be the larger number, so that means the smaller one's negative. And what could add to give us 7? This would. So I can rewrite that middle as, instead of writing 7h, I can write minus 3h plus 10h, or I can write plus 10h minus 3h. It doesn't matter the order in which I write it. Just know that both of those things do add to give us 7h. And then fill in with your 2h squared and your minus 15, whichever order you decide to put the 3 and the 10 in. So this bottom one right here, I'm going to factor by grouping. 2h squared and 10h have a 2 in common and an h, and if you factor out a 2h, you would be left with h plus 5. Okay, negative 3h minus 15. I do know that I want to take out a negative Since the 3 is negative, the leading coefficient is negative, I am going to take out a negative. 3 and 15 also have a 3 in common. So you would be left with h plus 5. So now we're left with h plus 5 for both parts. And if you took that out, you would literally be left with, like if you scratched it out, you would literally be left with 2h minus 3. Before we get started on number 5, I want to tell you to rewrite the problem. This is actually not the problem that we intended on being there. Negative 14h squared plus 11h minus 2. So we weren't intending on that 2 being positive like it was. Okay, so our directions are to factor it completely. There is no GCF. I was thinking maybe I could take out a 2, but 2 doesn't go into 11. That leading coefficient, however, is negative. So I do want to take out a negative 1. Let me change the color. Negative 1. And when you take out that negative, everything behind it changes sign. So 14h squared, a negative 11h, and a positive 2. So now we are no longer factoring this trinomial. We are factoring this trinomial. And the negative 1 out front really has nothing to do with the trinomial behind it now. So we're going to use that AC method right here. So the factors that would multiply to give me 28, but add to give me negative 11. And again, it's this negative 11 right here, not this positive 11, because we're not factoring that anymore. It's this. Anyway, if you're multiplying two things to get a positive, your signs have to be the same. So either both positive or both negative. But since we're adding these two signs together to get a negative number, they must both be negative. And if you look at 28, 1 and 28, 2 and 14, 4 and 7, let's see, if I made those both negative, they would add to give me that negative 11, and they would multiply to give me the 28. So let's rewrite the trinomial. Okay, so if you'll notice, I have just instead of writing negative 11h right here, I wrote negative 4h and negative 7h. So now instead of a trinomial, it's a four-term polynomial that I can factor by grouping. So in the front group, 14h squared and negative 4h. You can pull out, I was thinking you might pull out a 4. You cannot pull out a 4 though. 4 doesn't go into 14. You can pull out a 2 and you can pull out a h. 14h squared divided by 2h is 7h and then minus 2. Now let's focus on this binomial. Negative 7h and positive 2, they don't have a GCF, but the leading coefficient right here is a negative. So if the leading coefficient is a negative, factor out a negative, and in this case, it's just going to be a negative 1 that we're factoring out because they have nothing else in common. So that would leave you with a positive 7h and a negative 2. So now, if we pull out 7h minus 2, you're left with 2h minus 1. And then don't forget about that negative 1 that we factored out in the very beginning. Okay, and problem number 6, we're looking for what, and this AC method right here, like 1 times 5 is just 5. So you're looking for multiplies to give you 5, but what adds to give you 4. So the factors of 5 are 1 and 5 and 5 and 1. That will never add to give you 4, no matter what we change the signs to. So this trinomial doesn't factor, it's prime. When something doesn't factor, we call it prime. So looking at number 7, the first thing we want to do is look for a GCF. And there is one of 3. And you factor the 3 out, you're left with 10m squared minus 3m minus 4. So we're no longer going to be looking at the 3. In fact, you can just kind of put it to the side for your final answer if you would like. In fact, I'll go ahead and put a box around the final answer. I'm just not ready for that yet. Okay, so now I'm only focusing on the 10m squared minus 3m minus 4. So I'm looking for the things that multiply, the factors that would multiply to give me -40, but they must add to give me a -3. And we got that from the middle. So if we're multiplying to get a negative, our signs are different. If you're adding to get a negative, as in the -3, your larger number will be negative. So the factors of 40, 1 times 40, 2 times 20, 3 doesn't go into it, 4 times 10, 5 times 8, 6 doesn't, 7 doesn't, 8 times 5. I started repeating so I can stop. So now make your larger numbers negative, and positive 5 and -8 do work. So I'm going to rewrite this as 10m squared minus 8m plus 5m minus 4. Do remember, it doesn't matter the order in which we write the -8 and the positive 5. Just make sure their signs are the correct sign. It could have been 10m squared plus 5m minus 8m. It doesn't matter. Anyway, so now we're going to group this thing. We're going to group the front, and that has a GCF of 2 and of m. And if you factor out a 2m, you would be left with 5m minus 4. And on this binomial, there's not a GCF, is there? 5m and -4. So you're like, whoa, what have I done to mess this problem up? Well, I don't know. There isn't a GCF, so just factor out a 1 and see what happens. And look, if you factor out that 1, because there wasn't a GCF, we're left with 5m minus 4 on both. So if you factor out the 5m minus 4, you're left with 2m, and this is a positive 1 that we factored out. And then just don't forget your 3 out front. Looking at number 8, the first thing we want to look at is there a GCF? And there doesn't appear to be. I'm thinking at first that I might can pull out one of the variables, but like, for instance, A doesn't occur in everything. It doesn't occur right here. And then B doesn't occur right here. So we can't pull out a variable. We also can't pull out a number. So this is a trinomial. We're going to use the AC method. Just notice with this one, the A's are descending in power. Like here's a squared, here's a first, there's none right here. There isn't an A at all. The B's are ascending in power, as in there is no B. The first, the B is squared in the back. They just kept on getting bigger. But let's keep our AC method the same for right now. We're multiplying to get 8 times 3 is 24. We're multiplying to get 24, but add -11. Well, if you're multiplying to get a positive, your signs have to be the same. And if you're adding to get that -11, they must both be negative. And actually, 8 and 3 work. It's just that it would need to be -8 and -3. So instead of writing -11ab, I will write -8ab minus 3ab, because if you simplified -8 minus 3, you would get -11, right? So it's the same thing. And then I'm going to write down the 8a squared in the front and the 3b squared in the back. And we're going to do our same factoring by grouping. We're going to group the front and the back. So let's see what happens. In the front binomial, there's an 8 and an a in common. And if you factor that out, you're left with a minus b. And in the back binomial, there is a 3, a b in common, But I also need to make sure that's a negative 3 that I'm factoring out, because the leading coefficient, as in this coefficient right here, then the leading coefficient's negative, so I need to factor out a negative. So when I do that, negative 3ab divided by negative 3b is just a positive a. And positive 3b squared divided by negative 3b is minus b. So now looking at it, I have an a minus b in common. And if I take that out, I'm left with 8a minus 3b. On number 9, I'm used to looking for a GCF first. There is a GCF of 2, but before I factor out the 2, I do want to rewrite this in order as far as the largest power comes first, and then the first power, and then the 2 goes in the back. Okay, so this is the form of ax squared plus bx plus c. Anyway, I can factor out a 2, but now the leading coefficient, it's that negative 16, so I do want to factor out a negative 2. And what we're left with is a positive 8w squared plus 7w minus 1. So I'm looking for the things that multiply to give me negative 8, but that add to give me a positive 7. If we're multiplying to get a negative, our signs are different. If we're adding to get a positive, our largest number is positive. Our largest factor is positive. So the factors of negative 8 that add to give me 7. Well, 8 and 1, let's try that. If I make 8 positive and the smaller one negative, that would multiply to give me negative 8 and add to give me positive 7. So that works. So I don't want to forget my GCF in the final answer, so I'm going to go ahead and format my final answer down here. And I'm going to rewrite the trinomial to say 8w squared plus 8w minus 1w minus 1. And if I factor out, if I group the front and the back, in the front group there's an 8 and a w in common, you're left with w plus 1. And in the back group there is nothing in common other than the leading coefficient is negative, so take out a negative 1, you're left with w plus 1. So now we have a w plus 1 in common. You factor that out, you're left with 8w minus 1. Okay, looking at number 10, it's not in order. So we're going to rewrite it as 7x squared plus 23x plus 6. So there is no GCF, so we need to use our AC method and ask what multiplies to give us 7 times 6 is 42, but adds to give us 23. If you're multiplying to get a positive, your signs are the same. And if you're adding to get a positive, they're both positive. So 42, let's see, 1 and 42, 2 and 21. And actually, I think the 2 and 21 is going to work because they add to give you 23, they multiply to give you 42. And so I'm going to rewrite this trinomial as 7x squared plus 2x plus 21x plus 6. So again, instead of writing, and I'm sorry, I forgot to put the 23x right there. Instead of writing 23x, I'm writing 2x and 21x because that adds to give me 23. So now instead of a trinomial, it's a 4-term polynomial that I can factor by grouping. In the front group, there is an x in common. If I take it out, I'm left with 7x plus 2. And in the back group, there is a 3 in common. And we're left with 7x plus 2. So now if you take out a 7x plus 2, you're left with x plus 3. Okay, number 11. It is in order. That cubed was throwing me off, but it is in order as far as the cubed and the squared and the first power. I can take out a GCF of h, and that's it. I would be left with h squared plus 10h minus 24. So for the final answer, it will look something like that, okay? So now focusing on the h squared plus 10h minus 24. You're looking for what multiplies to give you negative 24, but what adds to give you 10. So let's see, 24. If you're multiplying to get a negative, your signs are different, and if you're adding to get a positive, your larger sign is positive. So 24, you got 1 and 24, 2 and 12, and I think that's it. 3 and 8, 4 and 6, 5 doesn't go into it, 6 and 4. And then making our larger ones positive, smaller's negative. Yes, it's 12 and negative 2. So because our A term is just 1, I really don't have to factor by grouping. I know that my factors are going to be h minus 2 and h plus 12. But if you're in that groove of rewriting it and making a 4-term polynomial, then by all means. So that's what I'm going to do for you. Instead of writing 10h, I'm going to write negative 2h and positive 12h, and then a minus 24. And in the front, there's a GCF of h, and you're left with h minus 2. And in the back, there's a GCF of 12, and you're left with h minus 2. So if you factor out an h minus 2, you're left with h plus 12. And so that will be your factors, other than the fact that you have a GCF of h. With number 12, you're thinking, okay, is this in order? It actually is. The fourth power, the second power, and then none at all. So it is in descending order, like it needs to be. Is there a GCF? Because you're kind of hoping there is with that f to the fourth power. You're hoping that you can pull out an f at least, but you can't. So we're going to have to factor it the way it is. Let's try our AC method and do it as normal. Factors that multiply to give you a 20, but add to give you a 12. And since you're multiplying to get a positive, the signs are the same, and you're adding to get a positive, so they're both positive. So factors of 20 are 1 and 20, 2 and 10, and that actually works, 2 and 10, right? So instead of writing, I'm going to leave f to the fourth the same and plus 20 the same. And instead of writing plus 12f squared, it's plus 2f squared plus 10f squared, because 2 plus 10 is 12. So this is essentially the same thing. It's just a 4-term polynomial instead of a trinomial. And once we write it as a 4-term polynomial, we can factor by grouping. So right here, I can factor out an f squared and be left with f squared plus 2. And right here on that second binomial, you cannot factor out an f squared, but you can factor out a 10. And if you factor that out, you would be left with f squared plus 2. And so now we have f squared plus 2 in common. Once you take that out, you're left with f squared plus 10. And those binomials there don't factor any further. On number 13, it's like, whoa, now this is an issue, right? This is too simple looking. So let's just look at it. It's in order. There is no GCF. we're looking for what multiplies to give us a positive 2 and adds to give us a negative 1. A negative 1, but the factors of 2, I mean, if you're multiplying to get a positive, your signs have to be the same. And if you're adding to get a negative, well, then your larger number they would both have to be negative. Anyway, there are no factors of 2 that will add to give you negative 1. So this one will not factor. It is prime. On number 14, it's in order. There is no GCF, but I mean, we're going to factor out a negative 1 because the leading coefficient is negative. So that means all the signs change. So now we're looking for what multiplies to give us 2, but adds to give us negative 3. So, and again, when you factor out that leading coefficient being negative, do remember this is the trinomial we were factoring now. It's not the original. Anyway, if you're multiplying to get a positive, your signs are the same. And if you're adding to get a negative, well, they both must be negative. So factors of 2, 2, and 1, if we make them both negative 2 and negative 1, they do add to give me negative 3. So instead, let me go ahead and write the final answer format down here so I don't forget to put that negative 1 where it needs to go. But the trinomial of k squared minus 3k plus 2, I'm going to call that k squared minus 2k minus 1k plus 2. And again, I can rewrite that middle, that negative 3k, as negative 2k minus 1k. That's equal to negative 3k. And now it's a 4-term polynomial that I can group. The front group has a GCF of k, and I'm left with k minus 2. The back group does not have a GCF, but it does have a leading coefficient that is negative. You would be left with k minus 2. And now we have a k minus 2 in common. And if you take that out, you're left with k minus 1. So just put that into our final answer format that I had written for us already. And our last question just gives us something to think about. Is the expression 2x minus 3 times 4x plus 18 factored completely? Explain why or why not. Well, it is factored. It's a multiplication problem. Something times something, right? These are factors, but are they factored completely? And basically what we need to look for is if either of the factors have a GCF. So the answer is no, and this is why. Looking at 2x minus 3, that does not have a GCF. But 4x plus 18, I can really take a 2 out and be left with 2x plus 9. So 2x minus 3 times 4x plus 18 really equals 2 times 2x minus 3 times 2x plus 9. And I didn't have to write that in any certain order. But really the answer to the question was no.